So maths made easy. We are still taking numbers and numeration, and under numbers and numeration, we'll be treating indices. And in treating indices, you like to know, or you are supposed to know rather, this and this. Now, this is called the power or index in indices, and this is called the base number, right? The base number. So it can be alphabet. I'm just using alphabet to explain. It's called the base number, and we have the laws of indices, right? We have the laws of indices. Right? Law of indices says that whenever you have a base with a power and multiplying another base, the same base, the AA, use it AA with another power, what do? You just pick one of the base and add their power. So law of indices that if you have base A, you pick X and add it to what? Y. We also have law of indices that says once you have base A, X, base A, Y, not times now, divide. What you do, since for times, you subtract M. Since for multiplication, you added the power. So for division, you subtract the power, pick one base and say what? X minus Y. Another law of indices says that once you have A raised to power 0 is what? 1. Anything raised to power 0 is what? 1. Another one says anything raised to power 1 is that same thing, but it's not necessary. Meaning that if you have A raised to power 1 is what? A. We are not going to add it here. So we have 4. The fourth one, if you have A 1 over 3, what is it telling you? It's saying that the cube roots of A, two of them, they can interchange. 1 over 3 means the cube root of A. The cube root of A. So if it's A raised to power 1 over 2 is what? The square root of A. If it's A raised to power 1 over is what? The fourth root of A. So that's just it. Then we have the minus. But let me do this one first. We have this. We have A2 over 3. Now we all know that 2 means square. Now for this type, the numerator will always square, the denominator will always be the root. So we have the root, cube root of A all squared. It's the same thing as saying A squared then all cube roots. Right? So any of these two can work. Then we have the negative one. The negative one where we have let me write it here so it will be really bold for us. Let me write it here. We have the negative one where we say A minus 5 over 7. Let's do. We already know how to do this one. But before we do this, we want to remove the negative sign. Now in indices, when you want to remove the negative sign, what do? You divide by 1. So to remove the negative sign, you say 1 over, write everything again, except from what? The negative sign. So we have A 5 over 7. That's it. We are just removing the negative sign. We're not done. So we are now going to do it like this. So we have 1 over A, the 7th root, then all raised to power 5. All raised to power 5. So these are the basic laws of indices. And I'll just give us questions to solve, and we think we are done with that. So let's just take some questions, and we are done with that. So basically, for all the videos you'll be watching, I will encourage you that as you look at the examples, pick up your textbook, pick up your last question, pick up any materials that have to do with mathematics, pick up questions and solve. And if you have any questions or you have any issues, you can post it under the comment and we'll attend to them. Alright, so now we have examples, right? We have 2 raised power 3 times 2 raised power 2. Find the easy one. We have 2a, or we have rather 2a times a equals raised power what? 6. We have 22 b raised power 7 divided by 2b raised power 3. Then we have 2 raised power 4 times 2 raised power 0. And we have 3 over 4 raised power minus 2 over 3. Right? Now, the reason why I did this one is because the fourth law, the fifth law, and the sixth law, they are almost together in the sense that the fourth law has to do with the root alone, the fifth law has to do with the square and the root, and the sixth law has to do with the negative. So basically, if you can understand this one, you've covered the last 3 laws. So now let's solve. Now for this one, number 1, we have 2 root 3 times 2 root 2. They both have the same base. Pick 1, 2, 2. 3 plus 2 times 2, 5. 2 raised power 5. That's what indices. That's indices. 2 raised power 5. You can decide to make your answer 32, but the real indices, you must have your base and your index or your power. Now the second one, we have 2a times a raised power 6. Now these two is not the same with this. Now there is a visible 1 here, so just 2 times 1 is what? 2. The same, what is the same is a and a. You pick 1a. And for indices, once you don't have anything raised to power, right, is invisible raised power 1. Raised power 1 is always there, so we just say 1 plus 6 is raised power. Once you see anything, if you see 2 does not have power, it's raised power 1. If you see 100 does not have power, it's raised power 1, because n raised power 1 is the same thing. That's what I was trying to explain in the law that I say it's not necessary. So we have 2a 1 plus 6, so we have 2a raised to power what? 7. Now the third one, we have 22b 7 raised power 7 divided by 2b raised power 3. Now what is common here? This b and this b. So we can just pick 22 over 2. Then pick 1b. 7. What do you do to their powers? You subtract them. So 22 divided by 2 is what? 11b. 7 minus 3 is what? Raised power 4. So this is our answer. Now for the final one, number 4, we have 3 over 4 minus 2 over 3. Right? Now, here, to remove the minus, what do? We say 1 over 3 raised power 4, right? 3 over 4 rather, raised power 2 over 3. Now, how do we do it? Right? Normally, okay, let me change the question so that it will be quite easier for you, because this one, if you square it or you do the cube root, it will not work. So let's change it to something like 27 over 64. Let me change the question. Pardon me for changing it. 27 over 64. So that it will be quite easy for you to understand. 27 over 64. 27 over 64. Now what do you do here? You do 1 over 27 over 64, right? You do what? The cube root and you square. So 1 over, what is the cube root of 27? Cube root means that what number can you times 3 times? That same number, you multiply 3 times, that will give you 27. And we have what? 3. 3 times 3 times 3 is what? 27. Over cube root of 64 is what? 4. What number can you times? That's 4 times 4 times 4. That's what? 64. That's 4. So we have square. So continue from here, we have what? 1 over 9 over 16. Mathematically, this is wrong. You cannot have 2 over, right? So you separate them as 1 divided by 9 over 16. 1 divided by 9 over 16. Now, remember when we are doing multiplication and division of fraction. Change the division to what? Times. Then what happened? The 16 comes up and the 9 goes down. So we have 16 over 9 equals to 16 over 9. That is what type of fraction is this? This is what? An improper fraction. So we can just change it to mixed fraction. That's what? 2 whole number 7 over 9. So I think that's all for indices.